Hi, welcome to my video, and today I'm going to show you on how to find the vector equation, parametric equation, and the symmetric equation by the point given. So let's go over the basic behind this. So let's say we have a 3D coordinate system, which is x, y, and z, and we're gonna have a generic line. Now, line is defined by two things. We need a point on the line and the direction on the line. We have two things, we can define any line. So let's say that we have this point, which has a value x0, y0, and z0. This is gonna be a position vector r0. And let's extend this another vector. Let's call this vector g. If we added those two vectors, if we take vector sum of those two vectors, it will give us the position of vector r. Now, r is the vector sum these two vectors. Now, vector g is going to be a parallel to vector v. Because they're both parallel to each other, g is going to be some scalar quantity by multiply by v. So we're gonna set t times v, so that we have the vector equation on the line, which is r0 plus t times v. So this is the formula that we're gonna use in order to write the vector equation for this problem. Now, some other things you want to keep in mind is that the position vector r0 is equal to s0, y0, and z0, and v defined by this value. So we're back to solve this problem. In this problem, we need to find the vector equation, the parametric equations, and the symmetric equation for the line through the point P, 1, -2, 5, and Q, 3, 4, and 6. And then we need to find the points at which the line from this problem cuts the coordinate planes. So how to solve it? So our vector will be vector PQ, and that's gonna be difference between points Q and P. And then we will get now that our vector will get that 2, 6, and 1. Now, point P, let's say that it is our standard point. So now we have the value x0, y0, and z0, and this is gonna be A, B, and C. So now we have everything we need in order to find vector equation, parametric equations, and symmetric equations. So let's start with the vector equation using this formula. So R0 is going to base on the point 1, -2, and 5. So as a vector, it's gonna be like this. We take from this 2, 6, 1, and then we write it as 1i plus -2j plus 5k plus vector times multiply by t. We'll get the t times 2i plus 6j plus 1k, and then we factorize them, and then we will get the vector equations is 1 plus 2t I plus -2 plus 6tj plus 5 plus tk. So next is how to find the parametric equations. We can find them directly, but we're gonna use this formula. The formula for the parametric equation is s equal to s0 plus at, y equal to y0 plus bt, z equal to z0 plus ct. So we'll put this from the formula and we'll get this answer. Okay, next we're gonna find the symmetry equations using this formula. We have this formula: x minus x naught divided by a equal to y minus y naught divided by b equal to z plus z naught, z minus z naught equal to c. And then we'll put this into this formula and we'll get x minus 1 divided by 2 equal to y plus 2 divided by 6 equal to z minus 5 divided by 1. So that is how we find the vector equation, parametric equation, and the symmetry equations. Next, the question says that we need to find the points at which the following of problems in A cuts the coordinate planes. So all we need to do is we need to know that the line cuts when z equal to 0. So we take from the symmetry equations and we put z equal to 0 and we'll get this answer. And then from this we'll get that this will give x equal to -9, y equal to -32. So the line cuts at the point -1, -32, and 0. So that's how you're gonna solve the problems from these problems. I'm sorry. That's all. Thank you.